Alternators and dynamos are two types of electrical generators that produce electricity by using the generator effect. The generator effect is when a wire moves through a magnetic field and an electric current is induced. Alternators generate alternating current, which means the current constantly changes direction. Dynamos generate direct current, which means the current flows in one direction only. Even though they both work using the same principle, the way they produce current is slightly different. In an alternator, a coil of wire spins between the poles of a magnet. As the coil spins, the direction of the induced current keeps swapping, which creates alternating current. Alternating current increases smoothly to a maximum value, then decreases and reverses. That is why the current goes plus, then minus, and repeats again. Dynamos are similar, but instead of using two sliding rings, they use a split ring commutator. The split ring changes the connections every half turn, so the current always leaves in the same direction, which creates direct current. Direct current rises and falls in size, but the direction stays positive. To see this difference clearly, we use an oscilloscope. An oscilloscope is a screen that shows how voltage changes with time. Alternating current appears like a smooth wave that goes up and down above and below zero. Direct current appears as a wave that stays above zero. Dynamos were used in older bicycles to power lights, while alternators are used in cars and power stations. Alternating current is used in homes because it is easy to transmit long distances using transformers. Direct current is used in devices like phones and laptops because they need steady one-direction current. Even though alternators and dynamos look similar, the small change in how the coil connects makes a big difference in the type of current produced. The oscilloscope pattern makes it very easy to tell which one is producing alternating current and which one is producing direct current. Understanding this helps us see how electrical generators power the world and why different devices need different kinds of current.